Yeah, today, grade 9, our scientists. Right, it's like our lesson was not completed since we were cut off before we finished with all the questions. So just continuing from where we left in the previous lesson, we ended up on question 1.5.1. That's what we have here. And what I did is like I added a little bit of more information onto our script where we were answering questions. That is as is shown on my right hand side screen there. Now, it's like the additions that I added or that I put in. It's like if we are to check on 1.3, the current, then it says A4. A4 is the ammeter number 4, which is equals to ammeter number 1. So the way it is written here, the subscript, it's not written in the same way as is on the question. So please bear with me. Right, then there is a red line. Whatever is written after the red line is the reason. So we are saying the current that is measured by A4 is equals to the current that is measured by ammeter number 1. The reason being that the ammeters are in series, right? So there are series connection. Then on 1.4.1, again, Ohm's law says voltage is equals to current multiplied by resistance. So I represents current, R represents resistance. So that's the formula. Then we substituted, that is V2 or the voltmeter number 2. So the voltage there measured by voltmeter number 2 is equals to, then I substituted current by 0.2 amps multiplied by 10 ohms, which then comes to 2 volts, all right? Fine, it's just some of the additions that are included. Then 1.4.2, the total voltage is equals to the sum of voltages across resistors in series. So whenever resistors are connected in series, the total voltage supplied by the source of electricity will be equal to the sum of the voltages across resistors that are connected in series. So it's like now for us to find the total voltage across the source of electricity, according to the question, it's V1, right? Which is the voltage across the battery. It's V1. So it's the voltmeter number 1 is equals to the voltmeter number 2, that's the voltage across R3, plus the voltage across resistors that are in a parallel connection. So when we add those voltages, they give us the sum of the voltage supplied by the source of electricity. So that's the idea that we used there. Then we were on number 1.5.1. So that one, we answered it as well. And in that case, we were asked to find the reading on ammeter number 2. So the idea that we use there is simply to say the voltage across parallel resistors is the same, right? Which means the voltage across R1 is equal to the voltage across R2, right? So which means the voltage across resistors that are in a parallel connection is the same. So that's the idea that we use there. So the voltage across R1 or resistor number 1 is equal to voltage across resistor number 2. Then we then substitute by saying, looking at the voltmeter number 3 by Ohm's law, it's equals to current multiplied by the resistance. So the current that we are going to make use of is the current that is flowing through resistor number 1. And we must also know the resistance of number 1. So in this case, our voltage the voltage across R1, it's V3. So we substituted the voltage and the resistance. That's the information which is given. But before we substitute that, I had to make ammeter number 2 the subject of the formula, which means the current that is flowing through resistor number 1 is equals to the voltage divided by resistance. This formula is just derived from Ohm's law. So thereafter, I then substituted voltage across resistor 1, which is V3. It's 1 volt. We calculated it on question 1.4.2, which is 1 volt divided by 10 ohms. So 1 divided by 10 is 0.1. This is now what? Current. So voltage divided by resistance is current. That's 0.1. Now, we are moving on to question, that is question number 1.5.2. That's what we are supposed to be dealing with now. Sorry, I have to make use of a blue color, not red. Right, going back to the question. On 1.5.2, we are supposed to calculate current that's measured by ammeter number 3. Right, going back to the diagram, our current measured by ammeter number 3, it's this one here. So it measures current going through resistor number 2, as is shown by my pointer there. All right, so for us to find that current, remember, we are to use the same idea that we used in 1.5.1 to say, for us to calculate the current here, we must know the voltage across R2 and we must know the resistance. All right, so by Ohm's law, it says voltage number 3 that's V3 is equals to, then we have current. The current, it's A3 multiplied by the resistance of resistor number 2. This is what? Ohm's law. Then from there, since we are to find current, I'm going to make current the subject of the formula, which means I transpose resistance, which means it is now equals to voltage number 3 divided by resistance number 2. All right, then from there, I'm then going to substitute voltage, it's 1 volt, then we divide by resistance, which is 10 ohms. Right, so please note, do not confuse yourself with the 0 and O. I did not use the capital letter there to avoid confusion. Then 1 divided by 10, we get, that's 0.1. And it's amps, right? So that's the answer there. Then we move on to 1.6. 1.6. Now, but before I move on to 1.6, if you check on the current flowing through ammeter number 2 and ammeter number 3, you can see here that the current is the same. the current is the same. Why is it the same? The reason being that the resistance for resistor 1 and resistor 2 is the same. So it means the amount of current that is going to flow through the resistors is also what? The same. Why is it the same again? Remember, parallel components share the current, right? So the current is 0.2. So as it flows along, when it reaches the parallel part, the current is going to split, right? Or the pathway is splitting into two pathways. Some of the current goes through R1 and some of the current is going to go through R2. So since the resistance is the same, it means the current that is going to flow through the two resistors is also what? The same. That's what we have there. So it's 0.1 on A2 and it's 0.1 as well on A3. So when you add those two current, you get the total current supplied by the source of electricity, which is 0.2. All right. So if the resistors were different, it means different amount of current was going to flow through the resistors. The higher the resistance, the lower the current that will be allowed to flow through it, right? Now, let us now move on to question 1.6 now. Right, so on 1.6, we've said here, let's go to the question. 1.6 says, determine the resistance of one resistor that may be used to replace resistor R1 and R2. Now, check. Before you find the resistor that can be used to replace those two resistors, you need to know, are the two resistors in a parallel circuit or series circuit? If they are in series circuit, remember, the resistor that can replace resistors that are in series, you add the resistance. If the resistors are parallel to each other, then we have to use another formula to find that resistor. So in this case, R1 and R2 are parallel to each other. So which means we are going to make use of a certain kind of a formula that we are to use, which was derived by Ohm's law. Right, this formula here, since they are parallel to each other, it means that we have to say, allow me here, sorry, the shapes might not be all that good, right? So please bear with me. So we are now going to say let me make it slightly bigger so that I can try my level best to write it clearly. Right, so it means we are now going to say it's 1 over, that's the total resistance. This is the formula which was derived by Ohm's law. The T there represents total resistance. This will be equals to, then we say it's 1 over R, the two resistors which are parallel to each other. We've got R1, then we say plus, then the second resistor, there are two which are parallel to each other. So we add the reciprocals. Right? So we are saying, we are saying 1 over resistance total is equals to 1 over resistor number 1 plus 1 over resistor number 2. That's what we are supposed to use. If there were 3 resistors which are parallel, it means we were going to add the third one. If there are 4, we add the reciprocal of the fourth resistance here. right? Also, that's how we find what? The total resistance, right? So we'll then simplify the reciprocals, then we solve for the resistor T, right? So we are going to deal with that. Now, why are we using this? Remember I said this is because we are dealing with what? Parallel circuit. These are resistors that are parallel to each other. So it's parallel resistors. That's the reason. So I'm going to rewrite this, but I'll be using in word form. That's 1 divided by R total, which means the total resistance will be equals to 1 divided by resistor 1 plus 1 divided by resistor number 2, right? We are dealing with resistor 1 and resistor 2 because these are the resistors that are parallel to each other. So which then means that we are saying it's 1 divided by RT resistor total, which is equals to, then I'm going to substitute now. Resistor number 1 is 10 ohms, right? 1 divided by 10 ohms again, because resistor number 2 is also 10 ohms, right? So once you put that in your calculator, you are going to find out that 1 over RT, R total, is equals to 1 over 10 plus 1 over 10. You come up with 1 over 5. Right? That's what you're going to come up with. Now, what it now means here is we are now saying, sorry for using red here, then we are saying it's 1 divided by RT, that's the resistor total, it means this is equals to 1 over 5. So now, which means from here, what we are now going to do is simply to cross multiply so that we solve our RT, right? So we are first of all going to say we want to solve for total resistance. So since we have got one fraction on the left hand side, one fraction on the right hand side, that's when we can only cross multiply, right? So we are now going to say RT times what? Times 1. RT times 1, right? Then which means we are going to come up with total resistance times 1 is equals to, then we do the other cross multiplication. That's 1 multiplied by 5. 1 multiplied by 5. So it's 1 times 5. Then finally, you'll find out then that the total resistance, because RT times 1, it's RT, which is equals to 1 times 5, which is 5 ohms, right? So this is now the resistor that can be used to replace R1 and R2 that are parallel to each other. So as you can see here, before we converted to one resistor, R1 is 10 ohms, R2 is 10 ohms. But because we have used one resistor that can replace those two that are parallel to each other, the resistance then goes to what? It then goes to 5 ohms, which means resistance has been reduced by having resistors in a parallel connection, right? Why is this resistance reduced when resistors are connected parallel to each other? The reason is that more current is allowed to flow through it because there are now two pathways, right? So more current is going to flow through because there are two pathways. And in some cases, you will find out that some scientists or electricians say the resistor is now thicker. Why? Because we are now having two pathways, so it seems as if it's now a thicker resistor. More current is allowed to pass through it. That's the reason. Then let's move on to number 7. Determine the total resistance for the circuit. Total resistance for the circuit. Now, we now have one resistor to replace R1 and R2 that is parallel, right? So what it then means is R1 and R2 is now going to be replaced by 5 ohm resistor. Then we have R3, resistor number 3, which is 10 ohms. So it means we now have two resistors that are in series connection. That's R3 and the total resistance that replaced R1 and R2. So those two are going to be in series, which then means that since the resistors are in series, what happens to the resistance? It means we are going to add the two resistors. Right? Right, I just want to answer question 1.7 here. Right, so question 1.7, we are saying the total resistance or one resistor that can be used to replace all the resistance or resistors that are in the circuit is now equals to, then we just say, allow me to use again RT, right? For the total resistance is equals to, then we say it's let me make use of resistor circuit. Why am I saying resistor circuit? Because we have already talked about RT already. So there is one resistor that can be used for the circuit will now be equals to resistance 3. Then we say plus resistor total, right? Why resistor total? Because we use the resistance, total resistance for those that are parallel to each other, right? Why are we saying that? The reason is we are looking at series. That is resistors in series. Right, I'm just saying resistors in series. That's the reason. Then from there, I'm then just going to substitute, which means it is now equals to R3. R3 is 10 ohms. Then plus the total resistance for those that are parallel, it's 5 ohms, right? Then it goes to 15 ohms. So that's how we deal with the calculation of series and parallel circuits. So it's very, very important to take note of the type of connection that you have. Is it series or is it parallel, right? Then again, it's very, very important to take note of the information that you are given so as to be able to make use of Ohm's law, right? So that's what is very, very important. Is it parallel? Is it series? Then Ohm's law is V is equals to I times R. V for voltage, I for current, R for resistance. So voltage is equals to current multiplied by resistance. That's Ohm's law. Then whenever you are having resistors that are parallel to each other, then you must always remember that one resistor to replace resistors that are parallel to each other is equals to 1 over R plus 1 over R. It depends on the number of resistors that you'll be having, right? So that's it.